Hello, good evening or good morning, depends on where you are. Good evening or depends on where you are. Okay, so today we are going to do some Go coding. We are going to continue the project we are working on, and the project is GitHub Fire Hose. And if you are not following, this is a project in Go that try to model the logic as rules. Sometimes they call it business rule engine. And the idea is that you define rules, you try to react to an event, and you have preconditions to what kind of event you want to react to. And then you have an action, something you want to affect the system with, and then a destination, like the system you want to take that output and write it there. For example, you can listen to Kafka messages, and if they are valid, you can convert them to another structure and then write them to a database table. Or you can listen to a HTTP endpoint. When you get a request, you validate it with a condition, and then you do some action on it, which usually is your controller in the web apps if you are having an MVC. And this action will return some output, which is like output event, and then you can render it to like write it to HTTP response. Or you can write something else, like you listen to the same endpoint, but you can write something else to the database, or you can record some metrics. What I used it for so far, because we are still in the beginning, what I used it for so far is to listen on my machine on new processes and have a condition to match against the game paths or the commands that runs games. And then I form an output that is an update I want to do to Twitch stream. Like I want to update my Twitch. And after that, it pushes this event to Twitch. It actually calls Twitch and update the stream. So that means when I'm running the application, it continue to listen, and when I open Have a Nice Death, it's going to change the stream into Have a Nice Death. When I open Dead Cells, it's going to change it to Dead Cells. If I open the Mortal Kombat one, it's going to change it, and so on. Here also the last rule is Emacs. When I open Emacs, it it will update your stream to be Linux, Go coding, no AI. So this when thing is a source of events. It is a structure that should be emitting events. And this structure could be an interface for Kafka, or Redis, sets or queues, or it could be HTTP interface or gRPC interface. So anything that you can emit events from. What I used it here for is that this source is looking at the list of processes on the machine, and when it gets a new process, it emits an event for each one of them. This is all it does. And then in the rule, I'm matching with one of the attributes of the event. So if you go to this event, it has a set of attributes. I'm matching with CMD, which is the command line that runs this program. So when this is true, it's going to execute the rule. If it's false, it's going to skip it. So what this does is an action that just creates a static event, and you can use it to create any static event you want. So it just creates this event, and then I want to push this event to this destination. And this destination also implements an interface that takes the event and it uses the Twitch CLI to update my stream. So this is what we did. What we should do today is to continue with our to-dos. By the way, today I changed my audio setup, and I'm not sure if it's good or not. So I will depend on you to tell me if it's like too high, too low, because I got a feedback that my voice is too low on the past streams. So I will wait for you to tell me. I also did some improvements to it, like oh, thank you for the follow. I did some improvements to it, so like clipping and the noise gates and stuff. So it should be better. But also I'm catering it to my low voice. I usually have like lower voice. So I'm catering it for that. So it will take a bit of time to get used to this new level for me. So just let me know if I'm too high or too low. All right, so let's continue to work on our stuff. So here's the first thing, different granular return statuses for rules. So the idea is that when you have a rule, like main, like this rule either succeeds or fails. It doesn't have any specific other statuses. So either it's true or false. But actually there are other statuses, like this rule may be skipped because when this new process tried to match against this condition, it was false. So the rule was skipped. So it's not an error and it's not success. It didn't execute at all. So this should be probably a separate status. There is also when this condition has an error, or if this action has an error, or if the destination has an error. So maybe we can split each one of these. So I think we should introduce the idea of statuses. There you go. So we are going to define something that holds the return status of a rule. So let's call it type status, and the status it's either a okay, so all right, so maybe we can start with an int, okay, or maybe it could be an enum. That's all. Right, so it could be an enum, and then Go, it's like a type status int, and then you define an enum, right? So you define a type, and then you define an enum of this type. Status okay, status. It's completing for me. Status destination error. Yeah. Okay, so let's see. So status okay or success. And so either success or failure or fail. Success or failure. Yeah. So either it succeeds or fails. But also we have status no match. No match. Yeah. So you couldn't actually match the event with this rule. So this rule doesn't care about this event. Also the failure, maybe it's a failure of the action or the failure of a condition or a failure of the destination. So what failure is it exactly, right? So, okay. So does that mean there are two different categories of statuses, one that is success and one that is failure? So these are success and status a condition error, for example, and status destination error and status, yeah, action error, status action error, right? So because we have, if you look at the rule, so you have either source, condition, and action and destination, right? So each one of these can fail. Maybe this is what we need to check. Okay. So there's no failure. It's specifically one of these failed. Either the condition, the action, or the destination. It succeeds or it doesn't match at all. So maybe it doesn't match should be the beginning, right? Here you go. And yeah, now I'm not sure if you are trying to extend this list of statuses, then you need some kind of a function that define this new status, right? It should be the keep the maximum of the number and then it defines a new one. I think so. Like if you're defining a feature for the cache, for example, this feature can return a status, either it returned a cache hit or a cache miss. And the cache miss, maybe it can defer to that. So when it's a cache miss, it's either success or action error or destination. So that means if you have a cache feature, it should be able to define its own cache hit return status, just to tell you or signal to you that this middleware actually returned something from the cache, so you would know. And could be other stuff like validation. Instead of returning an error, it can return a specific condition, a specific status, that just to say that this, just to say that when it tried to validate, the input was invalid, or you try to validate the output and it's not valid. So there must be a way to define a new status. So here's the thing. Maybe we can do that. Maybe we can define an atomic, right? That's an N64, for example, and this is status counter, right? And instead of defining them as constants here, we are going to define a function. Let's call it a new status, right? So this new status should be a number. Yeah, exactly. So you add and you return. And that means instead of doing that, it will be new status. New status. It should look like that. And it's a variable. Oh, wait. Add, I think, what does it return? It returns a status, really. When you have this, it returns int64. Okay. Is there an int? Just an int? Is it possible? Yeah. New status, new. All right. So that means if you're trying to define a new status, you just call the function, it's going to give you a number. It's either int64 or int32. That's it. Right. So that means status should be int64. Come on. Yeah. So you have the type status, which is a number, and it's not a string because it will. If it's a string and you are trying to return it from a lot of these rules, so every rule will have its own return. So if you're just returning the same status, which is a string, this is gonna be probably have a performance penalty. So what we need to do is to make sure that we are using numbers, and maybe we can find a way to look up the status, the name of the status. So we can do that. Var status names. And this is sync map. Undefined the sync map. Here you go. And there you go. Yeah. So what we need to do is we can ask, when you're creating the status, you can give me a name. So this is like a name of the status. Here you go. And then status, we can add, and then var. So you can do that, right? Incompatible? Oh, really? Yes, in 64. Oh, yeah. Maybe I need to just cast it just to be happy. Yeah, it's happy now. And actually, because it's happy, I don't need to do all. I don't need to do all of that. I can just cast it right away. All right. So we can store that number with the new name. But yeah. So if you have the number, you can convert it to a name. And it could be vice versa, to be honest. You can have also another map that has the name and the ID as value. So the name key and ID value. So you can look up from the name to the ID and from the ID to the name. But we don't need the other way to look up right now. Let's have it one way. All right. So what you need to return is this. And let's call it status. Here you go. This is no match. Success, right? Condition error and status error, action error, yeah, and destination error. So if you have a feature for caching, for example, it can define in its own file and use status type and then use it to return whenever it needs. All right. Cool. So now we need to use it. Okay, so we need to go to the place where it executes the rules and return the results. And okay. So let's go to the place where we run the rule. So this is the rule. If you haven't seen it before, this is the exported part. So this is the data that the user will provide. And then instead of having an external list, like a linked list or a slice that we always append the rule to, and this rule also is generic. So that means if you have a slice, you can't have a slice of rules that are of different types. So what you can do is to have this rule as an interface and you can make a slice. But if you do that, you'll get a slice of rules. But also you will have another problem, that you will have to allocate memory and you have to copy the rule, right? Or like keep a reference for it. So you have to allocate memory in order to group the rules. So instead of that, what we did is something called the intrusive linked list. This is doubly linked list, and it's intrusive, as in when the user already creating their structure will already have the information we need to link the structures together. So it's not a node that includes the value of the rule. It's the rule that includes already the pointers. The pointer is null, which is the initialization value, then that means this rule is just initialized and it's not linked to anything. And then you can keep a reference to it and you can start to link together the rules. And that will allow you to not allocate memory, but also if you have one rule, you can go backward and forward. It's double linked list. So we use these two pointers to keep the whole rule linked together, and we keep these two pointers to keep the rules that has the same source linked together. And this is important because when you're executing all the rules that has the same source, you are getting the one event from the source, and then you are going over the rules for this source. So you are not getting, so if you have 100 rule, you are not initializing 100 sources and listening to the event. If they are the same source, then you can initialize it once, let it emit the event once, and then you pass it to all the rules, you as an engine. With that, you can like be more optimal. And we will try to do something similar for the condition, something similar for the action. So you can have the rules like linked lists over each other, kind of. So you are going to, just a second, what's up? So first you have a list of all the rules, and then you have a list of the rules that are in the same, that have the same source. And then you can also find the rules that has the same condition, the rules that has the same destination, action, and you can optimize, right? So yeah, so right now it's only about the same source, and we're going to add it later, so we can actually have that. So linked list for rules with same condition, so you don't have to evaluate the condition twice. And linked list for rules with same action, and the same for destination. Yeah, so if it has the same source, condition, action, destination, that's, yeah, same destination, that's the same rule. Yani that would be just the same rule. So I don't think we need that. Yeah. Anyways, so this is the rule. We need to go to the place where we execute the rule. And the first change we need to do is that instead of returning one value when an event is executed, so how do we do that? So let's see, you are, say here, you are adding a rule, you pass the condition, blah, blah, blah. Interface. Okay, so the interface for source, here's the interface for source. This is if you're building a source that is going to emit events, you're going to implement this interface. So it should implement a function that's called the start. It takes the context of the program. So when you cancel this context, it's gonna stop emitting events, stop what it's doing. And it takes a callback function. And it returns a done context and error. Error if it couldn't initialize. Done context is a context if the program canceled, the source should stop. If the program, if the source canceled this context, the program knows that the source stopped. So it's a way to communicate both ways, that yeah, you should stop, or you should, or the source actually stopped. And the idea is that you shouldn't, you can't just use the program context. We are trying to build it in a way that you can start sources and stop sources, right? You stop just this one source. So you shouldn't be using the program context to cancel that source either. Otherwise, you are going to cancel all the sources. That's the idea. So here, this callback is going to be called for the event. But when you execute the event, it will execute multiple rules. So we are returning one error here. So how are we going to return multiple errors? You see what I'm trying to say here? So we need to find a way for when the rules are executed, it should return its own status and maybe an error, right? So what we are trying to do is to return a status and an error. Okay, so this is the first thing, but we don't want it only for one rule. We want it for all the rules. And that means it can't be just this. two values. It can be, maybe we can have them as in a type, and we can have an array of this type or a slice of this type, right? So the callback return the status and error for every rule. Yeah, this could be it. But also to return a status and error for every rule, that means you'll have to allocate a slice and fill it in with the statuses and rules whenever you're executing the rule, right? And we're trying to avoid memory allocations. So this is the thing, I'm trying to avoid that my engine allocates memory. The source can allocate memory and everything, and then it can pass this memory to me so I can fill it in or pass in the values. So I think what we can do is to have maybe it should be a channel, right? Maybe the callback should return a channel, and this channel should have the status and error. Yeah, maybe it's two channels. One that returns statuses. No, because they are like pairs. Okay, so that means the status and error are two values that should be encapsulated together. Correct? So there is a container that should have these two values, and it should have like a meaning. So when the rule is executed, it's returning that. It's returning its own status and if there is an error. What do we call that? So I think this should be in the status here. So it's an encapsulation of this status and an error. Maybe the status itself should implement the error interface. That means the status should have also a pointer to the error. So either you have the status is itself the error, and that means when you're checking if error doesn't equal nil, you are checking with the status. If the status doesn't equal nil, the status could be no match or success, and these are no errors. So the status can't be an error. It has to be encapsulated in something else that has the error, right? Something else, yeah. Right. So maybe we can have a type that is it success or failure or any of these types plus the error type. I need some help with naming. If you have an idea of what to name it, please let me know. Write it in the chat here. All right. So you have a status and error, and the status error seems like very unclear. Maybe report status. Synonyms for status. It's like status report. Yeah. Situation. Ranking. Position. No. Synonyms. Posture. No. Voting place. State. State and it has status and error? No, that doesn't sound right. That doesn't sound correct at all. Let's call it report. So the rule reports, right? It report. And it's a status and an error. And you can get a string out of it, which will be the string of the status. Exactly. Oh, wait, no. So if you have a report and you want to convert it to string, So if you have a report that is like no match, you return no match, that's fine. So, but wait, I don't need the string yet, do I? Okay, now let's write it. Let's write it. Okay. So it's the status. There is nil. Okay, it's going to return that. Otherwise, gonna return this. Okay. Okay. So it returns. It want to return the status unless there is an error. It's gonna be the status colon and the error. That's fine. That is fine. And then you have the status. And now we need a function for new report. New report, status and error. And now we are allocating memory. Game over. If the rule called this new report, it's allocating memory every time. We can't do that. We can't allocate memory. Not on the heap. Ah, but this is returning by value, so it could be that it's actually on the stack. Can I check that? Okay, let's see. So this is returning. It returns a channel for read. And this is report. Report, right? So now instead of just getting, so you have a callback. The callback is going to give you a channel. This channel, you should continue to read from it until it's done. And this channel is going to give you all the statuses or the reports of the rules. And actually this will allow us to also execute the rules in parallel if we want, because this channel is like safe for synchronization. So you can just pass it around and push values to it as you want, right? And the source is responsible for pulling it and reacting to it. Yeah. Okay, so this is good, right? That's good. That is good. So now we need to go and see the usage of this start. Source process here. The callback is a read channel of report, right? Where was report? Yeah. Okay, this is too long. Yeah, that's too long. So how about we have this as a type? Have all of that as a type. So here, this source call back, and we are going to have it here. So type source call back. There you go. And it's of type T any. Source callback and of T. Yeah, so now it will be easy for us to just fire pose source callback of type. What's the type? Events process. Yeah, still too long, right? Source callback. Source CB. No. Source callback. Yeah. Yeah. Okay. And now when we have the callback, we are getting back not an error, we are getting back the reports. Yeah. And now you need to go over the reports, and if report doesn't have, if it has an error, we're going to print that. Yeah. Okay, exactly. So we're going to print the errors only now. And then we'll have something else that can maybe collect reports and log it. Yeah. So we can have a middleware that collects reports and log it. And the destination, the source doesn't have to do anything. It can just drain the report. And then the middlewares can be responsible for collecting reports and doing whatever we want with it. Bear with me. So interface. So in the interface, you have the start. Now let's look at where we are using the start. Nope, it's not the main, and it's in the rule. Here you go. So when the rule starts, it's going to start this. It's going to give it a callback. Here you go. Here is the callback. So yeah, the callback now is a channel that you just read from it, like a read channel that has reports. This is the same, right? Yeah, so we're changing, like we are going through the calls and we're trying to change it to accommodate for the new change we did, the return type. So this is the idea. Yeah. All right. So here, instead of returning, oh, there is also something we need to keep in mind. There's something we need to keep in mind. So we need to close the channel in the end, right? Something has to allocate the channel. There is something that has to allocate the channel. Okay, let's go across the code and do the change first, and then we can do that. So it's new report, and it's going to have a status. What is that? What? Oh, okay. Nope. Okay, so this run actually is running multiple things. It's the condition and the destination and like everything. So this run should also return the channel reports. And processing event enroll with source. No, we just need run needs to not return the channel, does it? Okay, here's the thing. This is the tricky part. Here we need to push to the channel. So this run should push a new report to the channel. Yeah. So we don't have the channel yet. Let's say we are going to create the channel here. So see. Yep. Nope, something is off. But wait. So we're going to run the first rule, send the report to the channel. And we need to return the channel. So that's the problem. The problem is that we are taking a channel, right? We are returning a channel here, but also we need to run the rule. And what I need is okay, so that means the source needs to get the channel, and then we need to go over the rules to execute it and push to this channel. That means there will be a go routine every time the source emits an event. Because you can't push to this unbuffered channel. This is an unbuffered channel. Let me describe it. So, Excalibur. That's the problem. So, here you have your source of events. This is the source. The source is going to emit an event, right? Here is going to emit an event. The event, let's say, it's like a process created. right? When it emits an event, it's going to call a function, which is the callback, right? So the callback now need to do two things. First, we need to get a channel from this one for read, which is the channel of reports. So reports channel, right? But also after we return that, the source should be draining this channel, right? So the source should be draining this channel. Anyway, so the source should drain channel, and it will drain the channel in its own go routine, right? So that means there are two go routines here. There is one that is pushing to the channel and one that is reading. So the source should be in its own go routine. So this should be here in a go routine, and this one here should be in another go routine, right? So we should have another go routine, right? And another one here, because this is an unbuffered channel. We don't want to allocate memory in order to push all of the hundreds of reports. We want it when it's created, the source can get it. So the callback here should be executing the rules. So here you should be having like rules execution, right? So at some point, this go routine should be created, right? If you are using channels to communicate, that means and it's unbuffered, then that means you need two ends to your application. And they have to be go routines, right? Because they have to run in like together. One of them is pushing and the other one is waiting to pull from the channel. So at some point, the source, when it calls the callback, in one of these ends, there should be a new go routine, a new channel. It returns the channel and the go routine continue. Right? Yeah. Right. All right. Okay. So, okay. So let's do this. Let's do that. So first, we need to differentiate between a callback that is actually so this callback is always here. So this must be from the source, not called internally. Okay. So why? Because I'm trying to create the report here, or create the channel here, channel, and we need to return this channel, right? And then there is something that has to take this channel and start to processing and publishing to it. So there must be something here that does that. And it should take the channel, which is C. And C is reports. So that means that this function shouldn't be returning the report, it should be taking the report. Reports. Should be taking it. Yeah. Here we are not making it. And run here is also taking the reports. Next rule, same. But let's first fix run. So reports. This is a read channel for report. Right, so we're trying to fix it one by one, and while we are going, we're trying to build on the idea and see if it actually goes through. I don't know if like I need to watch more Twitch streamers and people coding live, because I developed this flow, this way of thinking, just because I've been doing that for too long. in like side projects at work. So this is how I used to like think when I'm trying to build a project. Just to have an idea, just build it and then make it work, and then let's change something and try to adapt everything around it, then make it work, and then iterate and iterate until it becomes more polished. And this is why my side projects never ends. It's yeah, story of my life. All right, so we are not returning anything, just calling this with reports. Yeah, so you run the current rule and you run the next rule, and the next rule, you should take the reports, which is a channel of report. And we're not returning anything. If you return an error, just return the error here. New report and the status. Next same source. Oh, this is if you try to get the next same source and you couldn't. So this is, we need something to have a general error then. Because in this case, it's the source that failed. Maybe, I don't know, like this maybe is a general error. So we didn't have that. Status. Just a general error, like success and error, yeah. Then condition error, like specific errors. Yeah, maybe we can do that. So if you don't have a specific error, you can just use the general one. And we are not returning. Just see reports and you push it. Cannot send to receive only. Oh, Entschuldigung. It's not for read, it's for write. We need these to be for write. Yeah? Yeah. Exactly. Exactly. It's returned as for read, but then you pass it as for write. Alright. Right. Okay. Okay. So we have the run and this next same source equal nil. That means we don't need to do anything. There's no next. This is the last rule that has this source. So we don't need to do anything here. And here status error. Yeah. And here we're not returning. We call back with symbols. And report. Yeah. 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 What's wrong? Callback with symbols. Too many arguments for callback with symbols. Yeah, it's an interface. So reports, and this is a channel of report. Right? Because it's an interface, so cannot use reports variable that is a channel for write as a channel. Yep, same mistake. Does it work? Yeah, okay. Now we still have the error in line 70. You have the function run and you are trying to pass reports as the last param. And it should be here. And it's not for read. It's for write. Yeah. Yeah, now the error is gone. Now we need to come here. Oh, wait, it doesn't return an error. Now we are not returning the errors as a return value. Should process, if should process. Okay, maybe should process. So there are. All right, let's. It's not written like here. return. Oh, wait, there's something here that we missed. When there is not okay, that means you can't proceed. So you have to return here, right? You add to the report and you stop. Here would be the same. So you are returning, but you are not returning an error. You add, fail to evaluate condition, and return. Shouldn't process. Shouldn't process, that means skipped, right? So reports, new report, data skipped, no match. It's called no match. Yeah, no match. Yeah, it doesn't match this event, so it's not gonna execute this rule for it. You try to have the action and then reports status error. And actually the status error now tells us exactly what is the error. So you don't have even to have this font error if error, right? Because the status action error, right? It's called, we called it action error, right? Status action error, yes. And here the condition is the same. So condition error. Now you don't need to wrap the error. It's already wrapped, not with a string, but with a status. So I think this should makes it easier for the compiler to inline all of that and avoid the heap. Destination failed. Sure. Reports error destination return. In the end, if everything is fine, that means we need to report success. Condition, here it says condition evaluation failed. We don't need that, right? We can just do this. Yeah, because we already wrapped it when we called it. This should process when it's called. Here, status no match. Yeah, or if there is an error, we already say status condition error. So it's already in the report. Parse condition. Yeah, not related to us. Okay, okay. So I think we are done with this refactoring part. Now I want to see if this runs. Make run. Okay, it's running. It's like it compiled at least. It compiled. So now what I need to do is that I need to listen on any process just to see the logs. Just to see the logs, right? Okay, so all proc. I want to listen to all processes. So all processes when then we want actions yield, right? Because we're not doing anything to it, we are yielding the value as it is. To destination destinations, we have a destination called slog, which is a structured log. Yeah, and then we can register it. Can register it. Right. So that means when we run this program, it should listen on all the events. You run something, here you go. Here you go. Next rule doesn't have the same source. Current rule is this. Yeah, what's wrong here? Next rule doesn't have the same source. Why? So you have this rule. Event process and then Twitch stream info. Yeah. Okay, so this is the have a nice death rule. This is the current rule. Blah, blah, blah. to destination, and the next one is event process switch stream. Next one doesn't have the same. Can I see it? Can I just go and see where this error is? Maybe our refactoring made something wrong. Maybe we did something wrong here. Let's see it. Error incompatible source. Yeah. Okay. If it's not okay, yeah, we can't cast it. Yeah, exactly. This is it. So that's weird because all the rules that we have the same source. Okay. So let's see. Then let me copy all of that just to be a little readable. There you go. And firehose rule. So I'm trying to just make it a little readable. Yeah. If then yeah. Okay, and this is the next rule. Okay, so this is the next rule. So we have the first rule here and the next rule, and it says that the source doesn't have the same type. This source actually doesn't have the same type. Sorry. It tries to cast it to callable, right? Here you go. Callable. Tries to cast to call. Can I see this callable? It tries to cast to context, event, symbols, and reports. And this is implemented in the process source. Wait, maybe because the type here is not the same type, because we this here is now a type, right? Oh wait, yeah, it's different now, right? The source callback looks like that. So I think what we need to do, can we do this like callable is something that have a function of the same type as callback. Yeah, so maybe we can move them together, because when you have these, you see, that's the problem with generics and casting and stuff like that, that some errors doesn't show up until you hit it in runtime. So that's the problem. So we changed this type, we defined this type, and now this is different, right? So it can't be like that anymore. So should look like that. No, wait. Callback with Sims. Oh yeah, no, it's not related. It's because this callback with Sims and the rules, callback with Sims, we changed it here, but it was a function, right? It was a function and it was implementing this interface. We changed the function, but we didn't change the interface. Yeah. So all we need is to just change the interface as of it right now. Yeah. Right. So, oh, something else. We didn't close the channel. So you see, I'm trying to interrupt the program and it's just ignoring all of my stuff. So I have to terminate it like that. This is control and backspace. It kind of send what was it called? The traps. What was it? Control plus backspace. Function. Yeah, no. Bash. So what was it called? Or like Linux. It sends an interrupt, but I don't know which interrupt exactly. But it's an interrupt that tells the program to exit and print the stack trace. And this is really useful with Go because sometimes you have channels and you have like mutexes and stuff that are just sitting there and you don't know what's going on. So this will tell you. So you can see every Go routine and where it was stuck. Yeah, it's really useful. So what was the interrupt? Which interrupt? Control plus backspace sends through that process. Sends sig quit. Control C sends a signal interrupt. Control backspace sends signal quit. Is more aggressive, designed to quit the program and save its state for post-mortem analysis. And actually, if you turn on the what is it called? Heap dump. I think the heap dump. The program will also write dump the heap, and you can go and attach a GDB to it and check the registers and the variables and stuff. So you can debug your program afterwards, so you don't have to attach the debugger before you run the program. Now, when you do that, and the program already has like debugging symbols, it's gonna write this, and you can debug it. Okay, we didn't close the channel. We did not close the channel. So in the rules, I think this is the place we created the report. Yeah. And then we called this with symbol. So I think what we need to do is to call it, then close reports, and everybody lives happily ever after. So do that, and I run something. Here you go. It's printing every new process that is started. Bira, I think it's in the background or something. Lysine is, yeah. And this is the current working directory, and the bash started in, because I created, where is it? Here. I just started a new terminal, and the new terminal started the bash. Okay, it's working. Okay, so let's just stage that. Let's stage it. So now we have different statuses reported for every role. So I think now we have another source, which is time. And this time source should also do the same. It should implement the interface. Yeah. So that means I just want to close all other buffers. Where was it? Where is it? Where is it? Okay, let me check the chat. So, hey there, I'm sorry to interrupt your thoughts process. I saw you're looking with extremely long lines of text and parsing through it. I was curious if you'd be interested in seeing web IDE that help visualize lots of text in 3D at high performance. Well, no, I'm not. Thank you very much. Yeah, it's SigQuit. Yeah, it's SigQuit. You're asking about the signal, right? It's SigQuit. We already found this one. So No, and also these are long lines because I increased the font size so that it would appear on the stream. Because if you don't do that, the text will be too small, and some people are watching Twitch from their phones. I didn't know this exists even. I have the app on my phone, but I never really open it and start to watch. It's always either on my TV or on my PC, which is both larger screens. All right, all right. Thank you for the sub. Thank you very much. Oh, I really appreciate it. Thank you. Yeah, I think we have the goal for the subs is 10, and I think now we are 5. It's really nice. It feels like a game, streaming and having goals and trying to overcome it, and it feels like a game, but it's like more of a social game than just a video game. Yeah, we are 5 out of 10. Thank you very much. That really helps. What I learned in general is that uh, the subs and like monetization of Twitch is not that lucrative unless you really have a high number of subs and uh, and followers and like stuff like that and sponsorships and so it really needs a lot of work. That's what I understood, and I already have a full-time job, so I'm doing that because it really feels good to do it, and I will continue to do it until it doesn't. Do you plan to? Yeah. Um, well, I was actually watching the Primogen in the beginning. I discovered him on YouTube because they also have he has also like what was it, interviews and some clips there, and I watched it for a while until a certain political event happened, and his response was a little shocking to me. Like everybody is like entitled for his opinion, but his opinion was a little bit inhumane, to say the least. And this is why I stopped watching him, and I also stopped all the channels that had his clips from YouTube. So I don't see him anywhere unless maybe somebody have a screenshot on Twitter for him or something. Um, it's sad because he's like really entertaining and talented, but like I'm sorry, like I really have some kind of a basic bar that we should be all over it before we become humans, and it's yeah. Looks like a lot of Egyptians. Why? Yeah, I'm not streaming in Arabic because I had this choice in the beginning where I was thinking either I would stream in English or in Arabic, right? If I streamed in Arabic, only people that speaks Arabic are going to watch and follow, and yeah, so I would be limited to people that speaks Arabic and understand it. While if I watched, if I streamed in English, most of the people that speak Arabic and into technology and into Twitch and stuff like that, they already understand English. So I would be winning both people that speak Arabic and English and other languages, because English is now like ubiquitous language. Like a lot of people speak it, lots of people understand it. You call what we speak now English. Some people say that what we speak right now, it's not called English, it's like Globish, because it's kind of a global language that resembles English. Globish language. Yeah. So it's a name of for a subset of English language formalized in 2004 by John Paul Nerrier. It is a subset of the standard grammar and the list of 1500. Yeah, so some people say, yeah, this is kind of globish. There is English? What is that? Purism in the linguistic field is the English? Why is it called English? Why is English? Purism in English field. Linguistic purism in English is a reaction to the great number of... Okay, yeah, no, thank you. All right. Cool. Yeah, I think you know, Salah, what I'm talking about. Anyway, so this is the thing. If I don't like someone, I don't have to watch it. That's all. That he can do whatever he wants. He can be entitled to whatever opinion he has. That's okay. You know, we don't have to interact at all. Alrighty. Okay. So now we have our program refactored, but we refactored this source that emits processes. We need to also do the same for this one. So should have a callback, time callback. Yeah, no. So it's not time callback. Let's call it firehose dot callback, source callback, and the type is time. Right? And this is firehose source callback of time. Yeah. And what we do is we tick, and with every tick we are emitting, and with every emit we are calling back. Here you go. Here is the callback. So what you need is the reports, and should go for reports. If there is no error, if there is an error, we are going to log. Otherwise, we can ignore that. And the callback has, what is that? Cannot use events. Time now, value of struct type. What? So it's the context and the value, yeah, and it is then a report. Why I can't use it? Why? Event time now. Oh, yeah, I see your point. It's events time, not time. Yeah. So you see, this is why I like Go, because when there is something wrong with the type, it's gonna, you know, tell you, man, you have made a mistake here. Can you just fix that? Yeah. So this should work. And to make sure it works, we are going to write a test for it. Time test go. We just need to write a small unit test to make sure that it implements the interface. So this is the sources, and this is test for that, and trun implements the source interface. So firehose source, yes, this should compile. But also there is another way to do that. Cannot use function letter. Oh yeah, of course you can't. This will prevent compiling the tests in the first place. The test doesn't work if time doesn't implement the interface. So make test, this should work. But something else. So source make test or go test. Okay. So here it tells you that cannot use function blah 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 in line 11. Line 11. I didn't save, maybe? Yeah, I didn't save. Okay, so if your source didn't implement the interface, like it was error, for example, and here you return error, nil, right? So this is not the same interface, and you try to do this. Oh, come on. Wait, what? The interface is the start here, the start. So error, error, no, nil. Okay, so these are three params. So if you try to do this, it doesn't compile. This is the thing, it doesn't compile the program in the first place. So other tests won't even run. So this is good or bad, depends on how you think about it. But what I would like to try, because every time I actually require something triggered. Anyway, so require implements, yeah, the interface object, and the interface object is fire hose source ends on. So this is the interface object, yeah, and then the object itself, which is fine. Yeah. So can I do that? No. Okay. So maybe we can do it in a variable. So var this, and this is int or time source. Time source. Then you try to test, and it tells you, yeah, there is a failure. You see the difference between these two errors? This is a test that failed. This is a test, and where's the test exactly, and it failed. Here it's a compilation error. A lot of people do the assertion, even outside of the tests, to make sure that their structures are implementing an interface. I hate that, to be honest. It feels like a test in the implementation. Yeah, it's like the assertions that people used to do in C or C++. Kind of horrible. Anyway, all right. So if we fix the interface, we fix this interface, we are invalid memory address or null pointer dereference. Yeah, okay. Okay. What? This invalid memory address or null pointer dereference? Where is that? In implements. So how do we use it if not using that way? Testify implements. And implements. Require. Yeah, require, and there is implements. So asserts that an object implemented by the specified interface. Oh, okay. So pointer my interface nil. Okay, all right. This is actually what we are doing here. So this is fire hose source. This is events time nil. That's actually what we are doing. Yeah, exactly. So what's up with that? It says that it needs it to be pointer. So let's see. Maybe that's what I'm missing. So yeah, that's what I'm missing. So it has to be a pointer to the interface. Like it's the nil is a pointer to the interface. Okay, makes sense. The nil is a pointer to the interface. Yeah. Right. Now, let's see why the tests are failing. Yeah, the tests are failing. Oh my god. Oh my god. Okay. That's a lot of errors, and there is too many errors. This is in the engine test, engine test, engine test. Okay, let's go for the engine test first. First, let's stage that. Engine test. What's wrong, man? The mux. This is not implementing the source, right? This is not implementing your source. Yeah, I know what you mean. So this is the callback. And the callback should be returning a channel of report. Yeah. And here, what was that? Yeah, here. Channel or channel of report. Cannot use new source event mock value implements. So this does not implement wrong type of method start. Yeah, wrong type of method start. Is it wrong type? It's not anymore, is it? Enter. Let's look at the type. So a function that takes context and t returns channel and report. Yeah. No, that's correct now. Right? Am I missing something? I am missing something, am I? Cannot use new source mock value of source mock as source event mock value structure. So this source, the pointer to source mock doesn't implement source event mock. Source event mock, wrong type of method start. So have start that takes reports instead of source callback. Okay. So because we defined that as a type, so now everything that has this is complaining. I think I got it. I think I got it. Right? So that's the whole problem, is that this needs to be of source callback of event mock. Yeah. All right. Source. Okay. All right. And here we are not returning that, right? So this is a reports, and we need to do that, right? Yeah. ap event constrained by t. What's up with that? Event mock, source callback, event mock. Yeah, so that looks correct. What is it? What's your problem? Bless you. Bless you. Anyway, okay, so so we are calling this, and we're passing the event of t. Cannot use event which is constrained by any as mock, which is what? Which is what? Here, can I use event any as even to mock value in argument. Yeah, we need. Okay, yeah, I see. I see what you're talking about. I see what you're talking about. It should be T, right? Yeah. Now what's wrong with this one? So call back, and we are going over them. Oh, we are returning. No, we shouldn't return. What was this emit? What is it called? So it's not, this source mock is not called anywhere. This emit function is actually not used, is it? Yeah, it's not used anywhere. Only this, and this is actually referring to this emit, not the one in the mock. So actually, yeah. Cannot use this rule of type error argument to require no. Okay, doesn't implement error missing method. Which line is that? Rule. Okay, so we fixed the engine test. Now to the rule test. All right, let's go. Let's go. Call back. No error. Ah, yeah. Here we are always testing. There is no error. No error. No error. You see our problem now? So this is a channel. So we need to do this, right? It should be require, not nil. Is there like a require and the channel or something? No. Okay. So okay, so we're getting all the reports. There shouldn't be an error there. Here you go. So this should be everywhere. Error is error closed. Yeah. So this should be this is already called. What we need is report error. Here you go. So we are calling, and then we are getting the channel. The channel shouldn't be nil, and when you get the reports, you should get an error. But this doesn't tell you that actually there was an error. It tells you if there was a report, it has to have an error. That's probably the thing we need to. Okay, let's write a helper function. So function, which is reports to slice. Isn't there like a function that's like a channel to slice? I feel that I need it all the time. Do I have it in types? No, I don't have it in types because I have a package called types, and sometimes I add stuff to it. Let me see. Types. This is a utility package that I wrote so that when I need functions like that, I will just go and use it. Slice set map channel. Here you go. Channel map, channel filter, channel each. And there's no channel to slice, is there? Yeah, there's no channel to slice. All right. Channel to slice. And just do that, and we're done. So I think we need to drain right? So the report says chain to slice, and then so nil, and has to have one report, and this one report should be not an error. Should not be an error. Type int has no field or method. Oh yeah. I got you. Got you. Pip. Okay. So chain to slice. So we are going to do the same here. We're going to do the callback chain to slice. That means we are getting all the reports, not nil. Length is 1, 1. So this 1, 1. And when we get the report, it should be closed. Same is report chain to slice. Then not nil, len is 1. Then when you iterate over them, it should be report error. Yeah. Same. I think we have like multiple other ones that we need to do it. Actually, talking about other streamers, the streamer that I actually like now is Soding. His streams are really funny, and he is writing also in C, and is exploring some libraries that are really exciting for me. Like there was this one library that makes C similar to Go. It introduces channels and Go routines called libmill. This one. It makes C very similar to Go. It's cool. Okay. Right, so reports, to slice, no error. So there should be a two. Oh, we have two rules. Nice. Okay. And when we get these reports, there should be this. You see, the difference now is that instead of what the hell? Yeah. So instead of getting one error or not getting an error, now we get reports. You know, so it could be success, could be error, could be whatever. Reports, and we're doing that, and then it's not nil. We have one rule, is it? We have two rules. So the len should be 2. And if we are going over the report, should be closed, because one reported closed, error closed once. Yeah, so the first one is closed and second one is success. What's this test trying to test exactly? Callback chain stops an action. Error in first rule. Yeah, no, this is not true anymore. Callback chains the next rule with the same source. Yeah. So continue on action error in the first rule. So if you have a rule, it failed, you push a report that says that, yeah, it failed, and which failure is it? And then you go to the other, you execute the other rule. No, you don't stop. This was testing that it stops. So one here, that's action. Yeah, so one that's an error and one that is nil. So that means require the first one to be error and the second one not to be an error. Yeah. Call chain propagates error from second rule. This is the same, right? Same but different a little bit. So we also have two rules, and you are processing once. And here also it should be once. Right, so you have one rule called and return error, and the other one call and return nil. This is process. Yeah, let's move that. And you have 1 cent. The previous one also should have 1 cent. Yeah. This is the first one is error. The second one is nil. Here it should be the first one is nil. The second. So you propagate the second error. Okay? So that means they will be in reverse. So this, the first one, there's no error. The second one has an error. Call back with the 3 rules in chain. Yeah. So you process 3 times, send 3 times, and reports. When you collect the reports, not nil, and 3 of them, and all of them with no error. With no error. Incompatible type here. Okay. For reports here, nil, you get 1 report, and that report should be wire error, and the error is error incompatible, right? Incompatible source, yeah. What else? What was that testing? Let's call back with condition that evaluates to true. Okay, so we have reports, and you drain it, not nil, and then no error. You know what would be funny? After all of this fixes, I run the test and it doesn't work. Okay, like we are good. We are good. See, like line 347. 347. Yeah, it's the line we are in. So we are fixing. We are fixing it. Reports. Okay. All right. Attributes. Add rule. Channel to slice. Yeah. This is error with eval. Yeah. So that means we are getting also 1 report, but the report should be, yeah, this error closed, and I want also to test the status. The status equal, and the report status. Wait, what's wrong here? This is a report, invalid type. Interface. So where is the report? Oh, in the statuses. Status. Yeah, it's status. Yeah, exactly. So the condition is the one that failed. So the status should be that. Should be that the condition errored. Right? And here callback with faulty condition. The condition can't be even parsed. So the rule is not going to be created in the first place. Like it's not going to be added. Test. Okay, we have 1 failure. Okay, good. This is good. Success error. Next rule doesn't have sensors. Current rule. Yeah, what's the problem here? What seems to be the problem, officer? Call back with incompatible next rule type. This one. Yeah, so error contains, no, error is error incompatible source. Let me see what did we do exactly in the rule. So this is incompatible. How did we use that? So it's in the error, yeah. It's an error if and it's wrapping it. So what seems to be the problem? So it is this error. It just, so what is the error if it's not? So this is success error. Next rule doesn't have the same source. Success. No, it's not success. No. No. Okay, what's going on here? So call next rule. So you have success and then you have an error, right? So you have a success because this runs and works, and then the next one has an error. Okay, I think I know what's going on. So I think these are two, right? This array has two elements. One is success and one is error. Just this is space means it's just one element and then one element. So it's two statuses. When the next source is wrong, so it would be two reports. Yeah, let's match with every report. So the first one is not it doesn't have an error. The second one is the one that has incompatible source. Nice. Nice. We got it. We got it, everyone. All right. Perfect. So make lint. Okay, so we fixed this. Let's just stage that. Lists fixed and separate statuses. And let's mark this as done. Let's mark this as done and move it to done. All right. Now let's look at the lint because this will be the heavy part. Because we try to not have escape to the heap. And we just used a go routine in our engine. So our engine started go routines, which is a recipe for allocating to heap. Let's check it out. Like lint, yeah. Here you go. Here you go. Here you go. What's up? What's up, man? What's up? Okay, so hash try map. This is because I use the sync map. Right? I used the sync map somewhere when I was recording the statuses. So, do I make the status, because the status should be created on initialization, and the initialization is not in parallel, right? When you have the init functions, they run sequentially. So I will remove the sync map from there and so sync map, let's make it like a normal map, right? Status to string. Status to string, yeah. Okay. This is not load. We don't need to load. We just status names and you look it up. Then there's already a string. You don't have to cast or do anything. Okay. Okay, we are down to like small amount now. That was a lot last time. That was a lot. See that? Holy shit. All of that when you use the sync map starts to allocate to the heap all of this? Escapes to the heap, escapes to the heap. What the hell? Okay. Okay, where are we? Okay. Alright, potential nil panic detected. Observed nil flow from source to dereference point. In status 10, nil value assigned into global variable status. Where is that? In line 10. Okay, yeah. You are absolutely right. Escapes to the heap. Yeah. So this map escaped to the heap. This map, and this map is for us to convert any status number to string. This is all it does, right? Isn't there a way to look up the variable name in runtime? Is there a way that I can use the debug symbols to trying to avoid the heap allocations is really tricky. So I can't use a map of status to string, but still I need to find a way to convert the number to string. Okay. And I need to be dynamic. So if there are multiple statuses and each one is a number, and we need to find a way to also increase that number over time and define new statuses, that means I can't have it as like a static enum. If it's a static enum, you can still have like a switch, like a function with a switch case on the type and is going to return the value. But what is happening here? What is happening here is that we are trying to use this map as a store so we can translate a number to string. So what happens if I reallocate it? No. Okay, let's leave that for now. Let's look at the next one. Maybe this one. Engine 88, context background, context escape to the heap. Engine 88, right. Engine 8. All sources started waiting for them to finish. Yeah, I need to find a way to not to log because I noticed also when I'm running the tests. So here, make tests. Make tests. It logs, right? So if there is a failure, it logs actually. Go run test. Go run test. Go test here. So it logs. Where was it? Here. This and this and this. You can turn off logging in testing, but actually the idea of logging inside your code, you know, like regardless, it doesn't feel good. And what I'm trying to do is that I just want to find a way to say, okay, like we actually started, and now let's wait for all sources to be done. That's all I need. And this can be in the main function. It doesn't have to be here. So I need a way to stop between here and here and print in the main. Yeah. So this variable, where is that? Register. This is already an input. And this is already an input. So I guess we can have two functions. One start and one wait. So start, that's not blocking, just start, then wait. Oh, because you see, this is like start activates all registered rules and waits. Yeah, and let's do one of them. So this, and then this waits. So now let's call it, it's called anywhere else. So if I, anyway, so wait, right? And now I don't have to log here. And in the main, you can start, and the start is non-blocking. So you can say fire hose wait, but waits with, what was it? The registry, which is R, and the errors, right? And do we need the error channel in start? So we need this, and we need the error channel in case, yeah. So you can start, and everything is started, and then you can wait, right? And that means you can start multiple stuff, multiple engines, and then wait for all of them to be done. So we kind of deferred the logging into the main. If the main want to log, let it be. Let me close this. Okay. So let's see. It disappeared, right? Yeah. So now we don't have the slog as escape to the heap. It disappeared from the list. So now we have this in the status, and this escapes to the heap. This one, status 36. Yeah. Status 36. This part, and this part escapes because you are concatenating strings. Yeah. And why we are doing that? So this report, is this string called anywhere? Don't think it's called anywhere. So actually we don't need that, do we? At least not yet. And when we want it somewhere, some code will try to print the report. And this is why we're having it here. So maybe the other code can do that. Yeah, let's. Yeah, but I see where this is going. So I think the problem is that the status doesn't have a string function. So I think it's the status that should have a string function and should just return, right? Just return the name, which is S. Yeah. So we just need the status type, yeah, to have this string function. So if the structure of the status printed, it will just try to print the string of the status, and that's it. Yeah, there's no concatenation. Exactly. Yeah, we eliminated it. There's There's something here that I noticed. Where is it? Oh yeah, this part because it's not used and the standard output destination is not used, and this is why it says that it's unreachable because we never used it. We didn't use it yet. We just have it there just to be part of the library. So also, what is time ID? What is that? Why do we have ID for the time? Or the source ID return ID file. Yeah, we don't need that. We don't need it. It has a start, tick, emit. Yeah. And the event time has a string and attributes. Right? Sure. So the only thing that skips to the heap now is this. Map string status to string. And it skips because it's a global variable. How do I eliminate that? See the problem here? We need to keep a place where we map status to string. Is it too bad if I just have the status string, like the status instead of an integer to be a string? Is it that bad? So when you're returning it, you return a string and the string is 2 pointers, is it? Like what you are passing is the length and cap of the string? Or is it 3? Golang string size. String header size. Golang strings, yeah. Demystified, yeah, sure. What is it? A string is a slice of byte, sure. The first byte, strings are not array-wide. Okay, strings are read-only. Come on, man. Zero value of string is int string. Ranging over string. Okay, yeah, this is getting ridiculous. String. Okay, so where is the status? Maybe we can look at it in the standard library. Yeah, maybe we can look at it there. String. Here you go. A string is string. Okay, so a string is a set of all strings of 8-bit byte conventional, but not necessarily representing UTF-8 encoding text. A string may be empty, but not null. Values of string type are immutable. Yeah, that doesn't tell me anything. What's the cost of passing string and returning string in Go versus N64? So N64, it's just a number, right? So it's really easy to just put it on the stack and just go, just return it. It's equivalent to a pointer. But a string, it's a pointer and what? Length and cap, I think? No, there's no cap. There is only length. Yeah, this is 8 and this is 16. And this is because the Go header contains a pointer, which is the underlying byte. Okay, yeah, you pointed the byte. And the length, only length. Returning strength means copying 16 bytes of data. So we are trying to copy either 8 or 16. Yeah? So fits in one register, requires 2 registers. Never allocates on the heap, may allocate memory if the string is constructed dynamically at runtime. Yeah, if. And it requires 2 registers. And we avoid the heap allocation. Yep, let's do that. Let's do it. So That's just as simple as doing that. String. And actually you don't need a counter. And you don't need that. You don't need any of this. Oh my god, okay. Oh wow. So you actually don't need any of that. Oh, okay. You actually don't need new states, right? You actually don't need that. Uh-huh. You have a status and report, and yeah. All right. Let's see. Can't use status error variable of type string as a string value in array. Uh, rule 84. Rule 84. What? What's the problem here? There are 5 errors, yeah, and they appear here also. So 84, rule 84. Rule 84. Cannot use a status error variable of type string as a status value and argument. First, constant. Second, I have to repeat that. Do I have to? Or when I... Yeah, so if you use constant, the type is gonna repeat. If you use var, it doesn't repeat. Interesting shit. All right. Did we fix all the heap? Skip to the heap? Yeah, we fixed all skip to... Oh, we did it, everyone. Congratulations. Congrats. We did it. We eliminated all escapes to the heap. We did some compromises, but we did it. The outsend, unreachable function, unreachable... Yeah, so let's leave that. We need that. The unreachable, because these are stuff that we are not using yet, but we are going to use it. Do not define dynamic errors. Use wrapped static errors instead. Do not define dynamic errors. Use wrapped static errors. Yeah. Okay. So instead of this, okay. So there are two in Twitch stream and destination, and there are stuff in main. Then there is process, and there is main again, and then there is log and rule. Okay, let's look at the ones that are in the core. Yes. Comment should end it. Okay. Engine 7.3. Yeah, happy? This is rule 56. Rule 56. Right? This is rule 84. They say this line is 125 and it should be maximum 120. Makes sense. Makes sense. Okay, so 84. 84. This one, current. Next. Does this work? How long is this line? Okay. Make length. Right. So Rule 58 should use make channel report instead. Yeah, we don't need this 0, that's true. So rule 58, you don't need this 0, we already know it's not gonna be buffered. Status 19. Status 19. What does it say? Status 19. Exported function new report should have comment or be unexported. You are absolutely right. Now I have the full picture. Creates a new report with the given status. Yeah. Line 14, exported type. Exported type. Exported, oh yeah, so exported type status should have comment, exported type. So 3 here. Status represent the outcome of processing an event through a rule, indicating whether it was successful, if there is an error, if there is too much. Yeah. All right. We added comments. Let's see. Okay. So status, only the first constant in this group has an explicit type. And what's the problem with that? Sure. Happy? Right, so I'm looking for the stuff that are in the core, not in a subdirectory. Exported type, source callback should have a comment. And interfaces. Interfaces. That of processing event, including report represents source callback is a function. What? A function of type that sources use to send events to the engine. It takes a context and an event of type T and returns a channel of report which the engine will read from, which the engine will write to with the result of processing the event through each rule. So how many subs do we have now? Oh, we have 5. Yeah, we still need 5 to finish our goal. It's a nice game. They really gamified the whole Twitch. I feel I'm like too far away from Twitch that when I started using it, it feels like that there are a lot of things that I'm not used to. The like different ideas and different way of interactions. So I think I was streaming on YouTube a lot of gameplay, but I think Twitch is more rewarding. The feeling that you are actually streaming on Twitch and I don't know, the whole gamification and like following and like having this like overlays over your video and it's flashy kind of, it feels nice. So it gives you a little bit of more of an artistic freedom. So you can kind of express yourself in that stream. So you can add stuff and change colors and, get creative with it a little. While YouTube feels a little dry. It's, just give me the feed of the video and I'm gonna stream it to everyone. That's it. Which is what you want in a streaming platform, but still, a little flair would be nice. Right, let's look at that. Exported function wait. All right, it needs a comment. Wait looks until all rules have completed processing and sends any errors that occur during processing to the provided error channel. Anything else that is in the core package? I'm ignoring anything under these subdirectories for now, just because I want to first address the core. Yeah. All right. Does it run? It runs. Okay. What's up with that? Something somewhere didn't close the channel. So which channel are they waiting on? Oh, there's also something maybe we can do. So we can say wait, and you can wait for like timeout, and timeout is the time duration. Okay, and then when you are waiting, so here you get the context. Context is not nil. You are trying to select. Here you go. So let's select from this channel, or after timeout, we are going to write this case. Yeah. So you either the context is done or it exceeded the timeout. And now when you wait, you can wait for maximum time. So main here you can wait for like one like time second. Yeah. Now when you run, even if there is like a source that is misbehaving. Oh wait. No, it's still. Come on. What's up with that? Oh. Yeah, so we are selecting either from the context or after timeout. Next, you go to the next one and you do the same. What am I missing? What are we waiting on here? So let's look for the lines that says fire hose, because these are the lines that will tell you where we are waiting here. Engine 105, wait, 105. Error channel, we are waiting on the error. Yeah, I see. We used to have this in a Go routine, right? And then we removed it, but then we forgot that we need to wait in a Go routine. Yeah. And read the errors one by one. This is what was missing. Context deadline exceed. So this is, yeah, this is wrong because we are waiting after the program start. So I can't have a timeout here. I was wrong about this. I can't have a timeout here. Can't have it. Right? Okay. Oh yeah. Let's let's remove this and okay, let's run it. Started. Closed. Nice. Perfect. Perfection. Perfection. Okay, so make length. Let's see what else we need to fix. We are ignoring this and we are trying to address all of these threads. All of these threads. Oh my god. Oh, holy shit. Which stream? 88. Okay. Destination. Which stream? 88. What's your problem here? Don't define dynamic errors. Sure. I'm not gonna define dynamic errors. I'm just gonna make it as error. Errors new. Happy? And now you can do that. This is no game data found in touch. Okay. Error, no game found. Right, and then we can have it here as an error. Var, no game found. There you go. And let's have, oh, let's do this now. Which is, nope, this is wrong. Error, no game is returned when Twitch UI doesn't return any game data for the given name. Yeah, we can cut it down. So 118. Same? No, not same. I think it talks about this one. Yeah, because we added more lines at the top. No user data found in Twitch. Error, no user found. And here, error, user found. Okay. All right. Okay. In the missing field F. Yeah, it really needs to exhaust the structure. But that's fine. Missing field message and level. Destination is log is missing field. When we are logging. Yeah. Event process is missing field PID. Yeah, this is in the main. Okay, we know about this stuff because we are creating empty objects. Use of printf forbidden by pattern. I didn't remove that. So this is sources process. Source process. Printf. Can we slog error? Yeah. And you don't need to do that. Then main is too long, right? We're going to do something about I'm skipping main now because it's not important because this is just a usage of the package. What's important is the core of the package. Then second priority is the sub packages around it, and then the last priority is the main. String English, it's in the main also. Should end in a period. Comment. Destination is log 17. Destination is log 17. Comment should end in period. The Twitch stream. Twitch stream 18. Yeah, okay. and time 28. Sources time 28. Line too long. Source time 28. Oh yeah, this line is really long. That's true. I have a trick that I learned and I hate it. You just break down every parameter in a separate line. I hate it, but it works. I just don't like the style. Comment this one. Magic number 2. This destination is log 22. Destination is log 22. This is so it's like 2 attributes plus event. This event and these two. What do we call them? So you have the event label and value, and you have the event itself. Event address count. Yeah, most events count is 2, and this 2 is makes sense, right? I don't know how to describe that. Pair const pair 2. So it's like attribute pair plus event attribute count. Magic number 5 after 5 seconds. This is not magic. It's really self-explanatory. Source process 35. Source process 35. So process, and this is what when what happens. So every 5 seconds we are checking, right? So this is period. Periodic check, yeah, and then we can const periodic check is 5 seconds, and we maybe do that. Slog 29. Slog 29. 4. Oh no, 29 here. What's the problem? It needs continue with no blank line before. It needs here an empty blank line. Okay. And the process 25 return with no blank. Process, is it the event or is it's the source? Source. Says the return. Which lines? 25. Right. Continue with no blank line before. Continue. It's like process line 32, 39. 39. Continue with no blank. I think we did that already. This is this one. Then event, export the type event should have comment. Sure. Action event. So this event is actually emits a static event when processed. Returns the configured event as out. Yeah. Continue with no playing. We're done with this. With this. What's the type? Yeah, destination Twitch. Destination Twitch. The Twitch stream info. And this is also okay. Let's just clear that just to see how long is the list. after we fixed all of that. Yeah, not too big, because we will skip this main. Into which stream should end in period. Which stream destination should end in period. Action event 15. Action event 15. What's wrong with it? Unused parameter event. Yeah, we didn't use that, right? Because we didn't need it. Twitch stream go 29. Destination Twitch stream 29. And what's the problem with that, sir? Parameter context seems to be unused. This is the destination. It's unused when we're sending something to Twitch. We're not using any context, really. All right. Or no, like we should use a context, right? There should be some kind of a context here or there. This game ID, for example, doesn't take context. We don't need that. Broadcaster ID doesn't need a context when you are trying to get it. You for sure will get it in time. No. Here, this indeed. Is there like with context? Yeah, exactly. Exactly. So we should have a context. Because it could take time, you want to cancel it, the user just doesn't want to wait and will terminate, so you have to propagate the context cancellation. With context, city, yeah. This is game ID, there's also broadcaster ID. There you go. All right. With okay. And that means, oh, broadcaster ID should be broadcaster ID. Okay. Exported type process. So events process should have a comment. So anything isn't a process on the system. The process. Yeah, that is it. I don't think I need these. Do I need that to be public? Yeah, I need it, right? Yeah, I need to be exported. Return the current worker directory of the process. Executable path. Command line of the process. Yeah. So process, Twitch stream info 5, unexported type. This is events. Twitch stream info. We just need comments. Which is nothing now, which is fine. Let's run lint again, just to refresh the list. We have main, and then unused parameter context in process 16. Events process 16. We don't need this context for anything. This will be useful if you have an event but it doesn't have enough information, so you need to query the database, hit some system, call cache or something, so you need this context. But if you are getting everything from that structure, you don't need a context. But it's an interface, so we're not gonna remove it. Yeah. Which stream info go okay, event Twitch is an unused parameter. Event Twitch same, right? Same. Process go 15. Process go, and this is sources 15. what's emits event when new process are created. Yeah, I want also to improve it so that when a process is terminated, does monitoring a new process and emit event when they are created. True. And then destination is log 27. Destination is log 27. What's wrong with that? K is too short and V is too short. All right. So key value. Are you happy with that? I mean, K and V looks also like they are known, you know, like you don't need to expand them. And this is what I like about Go also, that you can use K and V and X and I, and it's easier. Missing white space above the line never cuddle declaration. Here. Did that, and then destination is log 24. Are we there? We are there. 24. Invalid statement above assigned. What? Missing white space above this. Oh, okay. And the process 79. 79. What's wrong with that? White space above this line, which is. Oh, this is source process. Okay. Sources process. This is line 7. 7 line. So what's the missing white space of this line? Invalid. So before the scan here. So if we run lint, now it should be better. Should be better. Let's see. This is main process. Calculated cyclomatic complexity of function, and this one to twitch and process. This is the destination. 9. This is too complex, and we need to simplify it. So destination twitch stream. Destination twitch stream, and it's this send. We need to simplify it. Okay, there's one thing here that we need, which is request should be T request event, right? Oh, and yeah, that's it. So func and T request and all of that. We need the context. All right, context. Yeah, and we return also an error in some cases. So we always return the request and error. So here, now we need the context and it returns an error. So we can do this. And then we marshal, and then we run the command that which CLI. Destination. Okay, let's see. Let's see if this solves the cyclomatic complexity issue. I hope so. Twitch stream 29. Yeah, 29. It's 6 and should be 5. It is 6 and should be 5. So we are that close. Yeah. So we have the broadcast ID and then the request. And how about we marshal the request inside the call of this function? Yeah. So instead of returning the request, we return just the body. And here So here we need to just return the body, which is, wait, maybe we can just do that. Yeah, and change the signature. This is a slice of bytes. This is nil, right? And now whenever we call the request, we are actually getting the request body. This should fix it. Yeah, it's done. So sources process 19. Sources process 19. And this is 10, and so we have to cut it in half. We have to cut that in half. This is all PID to process. Then here, okay, so the thing is, start is all just one go function. So maybe we can extract that. We can extract this select. For this for, maybe this long logic. Okay, might do that, comma, and then what was it? Because there was a function that the LSP export or like provide that I can use to like extract a function or something. Code actions, LSP execute code action plus what? LSP extract. Closure extract function. What do we call this? Check processes. No? Okay, sure. Yeah, all right. So here, and let's define this function. Check. Yeah, check for new processes. Yeah. Okay. All right. So, and this should be here. Check for new processes. If there is error checking, and we continue. That's all right. And here we should be returning error. Right, so return the IDs and so it's not the last PID, it's the current ID sorry equal current, yeah. So we wouldn't overwrite it unless there is no error. Mhm. Okay, and here we're not logging, we need to return an error. So found error if, and let's wrap this error. And this is source, and here when we pass, we should be passing the source context. Here it's just called the context, right? And the parameter is just called the context. Last PID equal PID. So return PIDs and nil. There's no error in the end. Here, what is that? So you call back and then you print, and from the reports you print the errors. That's fine. That's fine. Yeah. Okay, so let's check. Process, and then main, and the process. 19.7, and it should be 5. And this is line 19. This should be 5. Maybe we can have this context outside. Outside. So we are getting all the PIDs. If there is an error, you cancel and return. Yeah. Here, you also cancel and return. Maybe we can just remove this cancel and defer it. Yeah. Okay. All right. Last PID and then the errors, and if anything is wrong, you return. Yeah. All right. Then source and PID current. Hey. Hey. Right. It wouldn't help that we extracted the constant outside. Also, I feel I'm missing something here. Expected this for the... I feel I'm missing something, like I need to merge these two together. For the life of me, I can't remember, or I can't remember the syntax, or maybe it just doesn't exist, the idea that you merge two select cases together in Go. Anyway, also maybe we can extract this for loop instead of just this break outer, we can return. Yeah. Okay, so we don't break outer, we just return, right? Return. And you need two context, the context and source context. You check for new, this is the current, last PID, and then this outer, you monitor with the last PID. You continue to monitor, right? Yeah. You get the PIDs in the beginning, you monitor until everything is done. Yeah. Unnecessary trailing line. What is that? Source process 62. 62. 36. Okay, 36 maybe. 35. Unnecessary white space. Error string couldn't be capitalized. Aha. Error reading PIDs. 1. Okay, and this line is long, 59. 59. I think it calls, yeah, I think it's this one that is talking about. I need to get a better plugin to isolate the background. I feel this one is a little, I don't know, rudimentary, or like it's a basic. I don't know. Although it uses OpenCV, I see, and it uses some models from Onyx, I think, like one of these frameworks for machine learning. So it should be good, but the results are fine. And also it's a free plugin. And the problem is that a lot of things doesn't work on, like, people that build this kind of plugins don't make it run Linux for some reason. No, like, did people just forget about Linux when they are, like, every developer that I see right now, like 99.9% are using Macs. I've seen one that is using Windows. So when the companies are creating software now, they create it mostly for Mac and Windows. Mac because they are developers and use Mac, so they have to run it on their machines, and Windows because they know most of the clients are using Windows. So I guess that's why. But Linux, I think it's really a small segment of developers that are using Linux at work, which, although, like, at work, I'm using Linux, exactly the same setup. And a lot of things that I do works better on Linux or installed faster on Linux or simpler, like a library in C or something. But for Mac, especially the new Apple Silicon, sometimes things just don't want to work, or it needs a special flag. Yeah. Let's simplify this process. Sources process 40. So this is 40. The complexity is 6. Really? The complexity of this is 6? Where? Where is it? Where is this complexity of 6? Seriously? Oh, 40, 40, 40. Wait, no, that's... This is weird. Break. Maybe I can do that. Yeah? Maybe I can do this. Just remove one branch. This is 6, it says. No, it didn't work. It didn't work. Okay. Done. Done. After, and then you call a function. If there's an error, you break. Otherwise, you assign last PIDs to the current. Why would, like, how would I, what the hell? Ah, okay, wait a second, there's something wrong here, or? No. Okay, let's extract that. Let's extract this. as a... Wait, I don't need break, do I? Yeah, I need it, yeah. This is just a function call. What do I remove from here? This is just like for select, and here's... current error, check for new... I'm missing something? Am I missing something? Is there something I'm missing? Where is the branch that I should eliminate? Just 1, 2, 3, 4, 5. Okay. Check for new process. So maybe if there is an error, we can just log it here. Yeah, because I see this is logging. This is this is returning an error. So maybe we don't need that. Yeah. Maybe, okay, bear with me. So maybe we can do that. We can return a slice of integers. If there's an error, we are going to slog our way to it. Error, and we are going to... there is an error, so return last PIDs. Okay. And here we are returning the new PIDs. So if there is an issue, we are returning the last PIDs. And that means you can here last PIDs. And you don't have to do that. And there is no error even that is returned. Right? Yeah. Yeah, success. All right, so now we have the main and then process line 40, source of process line 40. Source of process line 40, okay, this one. And it says this is too long. Now you know the trick. Break the line. Main. Okay, perfect. So now let's fix the main. What's your problem exactly? So first, missing F, 75. This is the thing, I don't need anything in F in the first place. 7, 8. Fill the slog. Okay, and the message is new process, right? Or new. And it's info. Missing field. Yeah, okay. And line 84. 84. I think it's talking about this one. This is the thing. I don't need to fill in these with anything. Okay, example block. So this is events block, and fill this example block. Example block. I think the only thing will be that the main is too long. Yeah, main is too long, and the word English for occurrences make it constant. So I'll make the English word the constant, and then I will use the constant English instead of the English word. It's so dumb. But okay, main 90. This one is good. Variable name are 90. Variable name are it's registry, right? Okay, registry. And the word English is 4 times. Okay. So const English English. Okay. I feel dumb when I'm doing that. English. It feels really dumb. English. Right. So I just define the constant and then use string gaming has 3 occurrences. Yeah. So this is like a popular tags. Yeah. So I think you can do that. What was the gaming? Gaming. Right. String Linux has 4 occurrences. Why it doesn't say that right away? Why it has to like cut it one by one? Linux. Mm-hmm. Mm. Hey, I see. I see. I see. Hey. تعال تعال هات بص تعال 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 هات بص. ايه انت نايم؟ ها؟ شوف شوف شوف. All right, so main 19. And then the main is too long. That's we're gonna fix that. We can extract the rules somewhere else and we're gonna fix that. These rules, these we can okay, so actually we can just have the context in the beginning. Yeah. Just put the context in the beginning, and then your rules here, and activating them. Here, activate rules, and this is all the rules, and it returns the registry in the end, and it takes a context. Exactly. Here you go. And here you're going to activate the rules with the context and get the registry. What am I doing? What am I doing is a project that is a business rules engine. So you can have rules in specific format that looks like that. So you listen to events and you process it if it matches some condition, and then the output of that processing you can push it to another system. So you can listen to new processes, and if it's a certain process that you want to handle, you can do something to another system. In here, for example, I'm listening when I open Emacs, I'm going to change my Twitch stream information to Linux Go coding no AI. And this event, this output event is going to be applied to Twitch stream. In contrast to printing it to standard output, for example. And you can have other rules for games. So here I'm listening to Dead Cells game or Mortal Kombat, and then I'm outputting a fixed event in this case. This is a simple case. And write it to Twitch stream. So I update my channel information whenever a process that the system detects a process of a specific attributes. And the system can be extended in all of these different components. So you can get different sources. Instead of listening to processes on the machine, you can listen to RSS feed or HTTP endpoint or gRPC or Kafka topic or RabbitMQ. And the actions is whatever transformation you want to do to that event. The condition is a precondition that tells you if this rule applies to the event or not. So you can have like hundreds of rules that are listening to one source, and each one has a different condition to which events it should be processing. And then it does an action on this event. So it takes it and do something with it. That thing that it does is it transforms it to another event. Like when you get something, when I get a new process on the machine, I want to transform it into an update to my Twitch channel. And this update to Twitch channel can be carried over by the destination. So that's what I'm doing. Got it? Alrighty. So this is what I'm doing, yeah. And this system should be extensible. I just started 10 days ago, so as a daemon or a client, yeah, it runs as a daemon, yeah. So you should run it in the background, and it should be listening. So if you watch my yesterday stream or you scrub through it, you will see that I tested and it started to change my stream between Mortal Kombat and coding. What I was doing today is I was trying to improve the system so that when a rule is executed, it doesn't just return success or failure, like error or not, and it doesn't terminate on the first error. So now it executes all the errors. Like if you have one event that 100 errors are listening to it, 100 rules listening to it, it's going to execute all of them. Even if one errored, it's going to continue executing the rest of the rules. So the error is isolated. And also you get more granular status. So if you execute the condition and it didn't match this rule, the rule will return a report that says no match. So it will tell you actually that this rule, we tried to execute it, but this event doesn't match this rule, so we skipped it. or if you try to execute the action and there is an error in the action, it will tell you it errored in the action and then the error of the action, or error in the destination, or error when you evaluate the condition. So it give you more uh, granular status. So these are the statuses that it can return. And now you have a system that you can get events, and every event can fan out to rules, and every rule has a condition that's a gate, and then an action if the condition succeeded, an action, and then after that a destination where you want to carry over your stuff. And then every step, if there's some failure, is gonna be reported for this rule, and all of them are going to be reported back to the source, and the source can get all of these reports and do whatever they want with it. So the source can decide to reprocess the event, for example, or put it in a dead letter, or just ignore the errors, or it depends on how many errors exactly. So it can take a decision based on that. So what I'm trying to do is build like a core that is solid, that is strong enough, and doesn't allocate any memory on the heap as much as I can. So I have a linter here that will tell me if there is something escapes to the heap. So if there's something that escaped, it's gonna say, yeah, X escaped to the heap. Yeah. Let's fix this one. So this is what I'm doing. Yeah. Main 59. Activate rules is too long. Main 59. This is too long. All right. Actually, we can activate the rules right away. I don't have to have the rule in a variable. Yeah, I don't have to have the rule in a variable. I can just inline the rule directly. Right? So I can just do this. Yeah? Yeah. This should cut down the number of lines by 4, I guess. So here is the last one. Get ready, everyone. Right. So length. I think with that I should be clean. No, still too long. 65. I should be 60. All right. How do we cut it down? Hmm. Look at it. But this is the thing. Let's say I created another 10 rules. I have to have a function for it, right? So I need to find an exception. I think I have to have an exception for the file that has the rules. So I think I can do this. Rules.go package main. Yeah. And only this function, this file, is exempted from the long functions. Yeah. because I have to add more rules, and more rules will add more lines here. So I can't every time avoid having longer functions. So this is an activity, this is funlen. So let's add an exception. Golang CI funlen. Okay, exclusions. How do we have exclusions? Oh yeah, okay. A Golang CI length exclusions. How do we add an exclusion? Formatter product settings. No, okay. Configuration file. So this supports all options. Exclusions. Define a set of rules to ignore issues. Generated preset rules are here. So I think exclusions path. Is it exclusions rules? Rules path linter. Okay. So there is path or paths? Per path, per linter, per text, per source. Okay. Some linter from, yeah, okay. So rules, path, rules. And this is CMD, fire hose, and rules to go, right? And this is linters, funlen. So only this file would be excluded from having long functions. Anything else applies. Can't load config error in excluding rule 0. At least 2 of text source path except linters should be set. Yeah, exclusions. What's wrong? Is there like another way to exclude stuff? No. So what's up? Exclusions, and then there are rules, and then similar to the rules, there are paths. There are path except, so at least 2 of text source linters should be set. The command is terminated due to error. Okay. Rule 0, at least 2. So this is rule 0. It's linters. I guess that's the problem. That's the issue, right? At least 2 of text source path. Path. So it's path and linters. Yeah, perfect. All right. Let's add all of these fixes. All right. Okay. Okay, fix linter issues, right? Because we fixed all of these linter issues. Don't read from why. Ah, I didn't do that. Okay, just a second. Right, back. Okay, I was just unlocking my vault. Okay, so we are done with today's to-do. So we made rules be able to have different status reports. And the status report can tell you where exactly, what went wrong exactly. Yeah, so that's pretty good, I think. And we fixed all the escapes to the heap. We fixed all the linter issues. It's pretty clean. It's very clean. Tomorrow we can continue to try to have this extensibility part. Because if you get this right, then you can start to execute rules across machines. So you can have one process deployed on all the machines, and they can start to talk to each other and execute different rules at different times. So yeah, one machine can just be overloaded, so it start to distribute the load to other machines. Sub rules also is really interesting because you can have one parent rule that has the defaults, and then the sub rules are overwriting the parent defaults. Then you can have a function that collapse all of that into a list of rules. And then it will go as a normal list of rules. They are not different. They will have just like a pre-processing phase where you convert the tree of rules and sub-rules into flat rules. Yep. Linked list for same condition. Yeah, also if it's the same condition, we need to find a way to link them together. That would be easier because if you have the same source and the same condition, when you need to evaluate the condition once. You don't need to evaluate like 100 times. This should save you time. And if you already pre-computed that, if you already linked all of this together, you can just go through all the list. Yeah. All right. I think I'm done for today. It's been 3 hours since I started streaming. I hope that was useful. It was useful for me. I learned a lot, especially the way I can avoid allocating to the heap. It's pretty interesting. All right. I will continue tomorrow. And for people that are here, please don't forget to follow and subscribe the channel. That helps a lot. It kind of feels like a game I want to level up in it. So thank you.